Okay, remember that last time we uh, we did something on question 3 part 2. Yeah, we did something, so I just want us to finish this part probably before your next class. Yeah, so I think we managed to get the reaction functions for each firm. Remember, we said that we are dealing with a Cournot duopoly, and we said that this is this is a component of oligopoly, and we said that oligopoly is one of the market structures. Market structure is just the way a given market system is organized, right? So remember, we have got perfect competition, we have monopoly, we have oligopoly itself, then we have oligopolistic competitive type of markets, right? So the one we're dealing with here is and then we said that under oligopoly there are branches. So there's Cournot, there's Stackelberg, there's Bertrand, but in this particular case here, our focus is on Cournot duopoly, right? Where we said that under Cournot duopoly there are so in this case I've got two firms, right? So one is a follower, one is a leader. That's just the way that type of market is organized. So one will be a follower, one will be a leader, and then these two firms try to compete, right? They try to compete, and but in this case, they try to compete, and yeah, of course, the aim for each firm is to maximize profit, right? The aim is to maximize profit. So in this case here, we have a Cournot duopoly where these firms are facing an inverse demand function. And last time we said that an inverse demand function will always, so I'm not writing anything, I'm just explaining now. So an inverse demand function is one that starts with P, where price is made the subject, right? Yeah, that's an inverse demand function. Shockingly, it's like people are still struggling to an inverse demand function is one where price will be the subject, right? And then the normal demand function is one where Q, quantity, will be the subject. Okay, so last time we made the distinction between the two, and then we went on to get the reaction functions for each firm, right? Remember those steps. You get total revenue, you then differentiate it to get the marginal revenue, then you equate to marginal cost, you make Q1 the subject of the formula that is with the reaction function for firm 1, and then for firm 2 you do the same, you get the total revenue, and remember we said that total revenue is just price times quantity, right? Then after getting your total revenue, you come and differentiate this to get the marginal revenue. Okay, so marginal revenue is just the derivative of the total revenue function with respect to Q, right? After getting the marginal revenue, we come and equate this to our cost, and then we make Q1 the subject of the formula, and then we do the same for firm 2. We get the total revenue, we get the marginal revenue, and then we differentiate it to get the marginal revenue. Then after differentiating it, we then equate to marginal cost and then make Q2, the subject of the formula. So this we did last time, right? I'm just trying to draw a skeleton of what was done last time. So we're going to pick it up from where we ended last time, because today I just want us to look at how we calculate the equilibrium output, right? How we calculate the equilibrium output, given that we have the reaction functions for these two frames. Okay, so I'll write the reaction functions that we found last time, and then we'll use those to calculate the equilibrium output, right? Okay, that's okay. I hope I'm not confusing part 2 and part 1. It's that thing where you're doing the same question over and over and over, so I'm now confused. Just remind me, I think I'm lost. Did we do part 2 or we just did part 1 last time? Please remind me. I just want to be sure that we did part 2 as well. Mr. Senkara, can you hear me? Or anyone, please. Mr. Piri, can you hear me? We just did part 1. Okay. Oh, okay. Anyway, the logic is the same. The explanation and everything is just the same. Okay, cool. So if we did part 1, then I'm sure we got the reaction functions, right? We got the reaction functions and the like. Okay, so then we are going to carry on from where we ended last time. I'm sure we got Q1. We just found the function that was describing Q1. Okay, and we said that Q1 was minus 1 over 3 Q2 plus 50 over 3. Okay, so if you are behind on how we got this, just refer to the previous recording that I sent. In that recording, we discussed how we got to this stage. And then we also found a function that was describing the output that can be produced from facility number 2, and we defined this to be we defined Q2 to be 25 minus half of Q1. Okay, so what you do is this. Okay, so we are focusing on part 1, right? So the first part was saying provide the equation for the monopoly's marginal revenue, which we got, and then so we are now on part 2, determine the profit maximizing level of output for each facility. So remember what we did? We found Q1, we also found Q2. Okay, just the functions that were describing the output that can be produced from facility number 1 and also from facility number 2. So just a reminder, this is just a continuation of the last time's session. Okay, cool. So step number 1, to get the profit maximizing level of output for each facility. So after getting the reaction functions, okay, the first step is to substitute. Okay, so we do the substitution. So it's to substitute either, so you can choose here, either Q1 or Q2. Okay, so let's be specific. Let's say, can we substitute q2, right? q2 into q1. So remember, this you do the substitution after getting the reaction, after getting the functions describing the output that can be produced from the two facilities. Okay? Yeah. Okay, so our q1 is this, our q2 is this. Let me just see. Okay, I know people are trying to gamble between this and the other class. Okay, yeah, so we do the substitution. Okay, so where there is q1, sorry, where there is q2 in q1, we are going to put q2. In short, we have said that q1 is equal to -1/3 q2 plus 50 over 3. So what we're going to do is, since q2 is this, right? So since q2 is that, where there is q2 here, we are going to substitute that function there. We're going to put that function there, and then we solve and find the actual amount of output that can be produced from the first facility. Okay, so this is going to be q1 is equal to -1/3, open brackets. Where there's q2, we are going to put our 25 minus 1/2 q1 and close. Then we put the 50/3 like that. Okay, so what are we doing? We want to get the actual amount of output that can be produced from the first facility. Okay, how do we do that? We're going to do this by the substitution method. We're going to use the substitution method. So someone can decide to use q2 instead, right? And someone can decide to use q1 instead. The answers will be the same. So when you reach this stage, don't panic to say which function can I get and substitute in whichever. It doesn't matter. You can pick either q1 and put it in q2, or you can get q2 and put it in q1. The answers will be the same. Okay, so please don't panic there. Just do the substitution and solve. All right, so the next step there is just to open the brackets and solve. Okay, so we're just going to open the brackets and solve. So we're just going to open the brackets. In short, we're going to make sure that this 1/3 is distributed throughout. Okay, so -1/3 multiplied by 25, this will give us minus 25/3. Okay, then next is to do this. We multiplied by the -half q1 there. Okay, so when we do that, the negative, since the term there is negative and then inside there is also negative, remember, negative times negative, the answer is positive, so this will be plus. Okay, we're going to introduce the positive sign there. So plus q1 divided by 6. Okay, that is after multiplying, right? So the -1 times q1 will give us q1. Then 3 times 2 is 6. And we put back the 50/3. Okay, but remember, our target is to make q1 the subject of the formula, and then so that we can find the actual amount that can be produced from the first facility. All right, cool. So how can we do that? So when we reach here, we say the next step is to collect the like terms together. So can we collect like terms together? So collect like terms together. This means that all those terms with q, they must be on the other, like on one side, and those terms without q should also be on one side. So what we can do is this term here, the q1 over 6, since it has got q1, we can take it the other side so that it can join the other q1 there. Okay, so this will be q1 minus q1 over 6. Okay, this should equal negative 25 over 3 plus 50 over 3. You see that? Okay, so what we can do is on the left hand side we can make q1 a fraction. Okay, we can make q1 a fraction. Alternatively, so right now I'll try by all means to share with you those not really Crookes methods, but methods that will not be difficult for you to remember or to handle. So what we can do is to do away with the fractions, okay, because some people really find it hard to deal with fractions. So what you can do is, since we have got negative q1 over 6, you can convert this into a decimal. Okay, yeah, because really people find it easy to deal with decimals than dealing with fractions. Okay, so this minus q1 over 6 can be, so this will be q1 minus, so remember that q1 over 6 is the same thing as saying 1 over 6 multiplied by q1. You see that? So we can just deal with the 1 divided by 6 on the calculator. So you can just punch 1 over 6. You're going to get something like 1.6666. You see that? And then we can just correct that to maybe 4 decimal places, so that we can do away with the fraction. But for some, if you are okay with dealing with fractions, you can go ahead and use, and handle it as a fraction. It's okay. The answer will still be the same. Okay, but we can convert that, the q1 over 6, to 0.16667 q1, so that we make it easy for us to subtract the two terms there. So this is equal to, now another hint, on the right the denominator is the same. Okay, so these are gymnastics that we use. The denominator is the same. Okay, so every time when you are dealing with fractions and then you notice that the denominator is the same, that makes the work easier. How? You just add the numerators. Okay, so you add the top numbers, then maintain the denominator. Okay, so since we have got negative 25 over 3 plus 50 over 3, since the denominator is the same, the 3, we can maintain the 3, and then we say negative 25 plus 50. So negative 25 plus 50, the answer will just be a positive 25. You see that? So we can also convert this from a fraction into decimals. Okay, so we can just do 25 divided by 3, that is something like 8.333. It's okay. So this will be q minus 0.16667 q1 is equal to 8.3, like this. Okay, I know it's almost 30. So in this case, since the session has already started, people are free to go for the other session. It's okay. I'll still send the recording. Okay, just that we need to balance the game here, because two courses are demanding our attention at the same time. Yeah, so you are free. I'll still send the recording. You are free to leave and join the other class. All right, Yeah, so no, this is Q1. So after reaching this stage, remember the target is to make Q1 the subject of the formula. Okay, so when you reach this stage, it's to factorize. So can we factorize Q1 on the left? Okay, so can we factorize Q1 on the left hand side? So this means that we are going to factor out Q1. Okay, so Q1 into Q1. So this Q1 into this Q1 here, there will be 1 minus this Q1 into 0.1667 Q1. We're just going to remain with it 0.16667. We close. We equate this to 8.3333. Okay, right. And then after reaching this stage, okay, step number 4 is to subtract what is in the brackets. So subtract what's in the brackets.
Alongo, I can't see what you're sharing.
Really? Is that the case with everyone else? Mr. Chilombo, can you hear me?
Yes, I can hear you.
And you can't see the screen as well?
I am able to see.
Okay.
Yeah, even me, I'm able to see the screen.
Okay. Then it could be, yeah, those issues, internet connectivity and the like. But don't worry, I'll still send the recording. Sorry about that. Okay, yeah. So the next step is to factorize what's in the bracket. So sometimes when you log out, you log in, the problem stabilizes sometimes. Yeah. Okay, yeah. So after reaching this stage, right, you subtract what is in the brackets. Okay, so in the brackets we have got 1 lesser 0.16667, which will give us 0.8333. right? So this will give us 0.8333. Q1 is equal to 8.3333, like that. Then from here you just divide throughout. So you divide throughout by 0.8333. Why? Because we want to make Q1 the subject. So in short, on the left we should just have Q1, nothing else. We just want Q1. Okay, we just want Q1. So this will be 0.8333. Q1 is equal to 8.3333. Then this side we divide by 0.8333. Even this side we also divide by 0.8333. We cancel those so that Q1 can be. Then now we do the division there. Okay, so when you do the division, we're just going to get 10 units. What does this mean? Well, it means that this firm will be able to produce a total of 10 units from first seat number 1. So from the first branch, this firm will be getting 10 units. Okay, but remember, we have got 2 plants here. There's plant number 1 and then there's also plant number 2. So now that we know how much can be produced from plant number 1, our work has been simplified because we can easily calculate the amount that will be produced from the other plant. Okay. How is this so far, Mr. Sinkala?
As usual, explanation is straightforward. And my strength is the recording. I know after attending this class, I'll still enjoy the recording for deep understanding.
I see. I see. Okay. Anyone behind? Please feel free. Remember, now we are racing against time. So if you don't ask.
Mr. Lungu, me, I'm behind.
Yes, Madam Monde.
The issue is that I still can't see.
You still can't see.
No.
But the other members are saying that they are able to see the screen. So, maybe you try to switch the provider, the network provider. You can try to the other, maybe the green or the yellow.
Monday, log out, then log back in. We're able to see.
Okay, I'm sure. Yeah. Okay, cool. Yeah. So now we have managed to get Q1, right? We can then get Q2, but the question is, how do we get Q2? Well, remember that we have a function somewhere that is describing the output that can be produced from the second plant. Okay, and we said that Q2 is equal to 25 minus half Q1. And now, since we know what Q1 is, okay, so to find Q2, step number 1, substitute. So substitute Q1 with, remember what we found? The 10. So here where there is Q1, we are going to put the 10. Because we have said that this firm can produce 10 units from the second facility. Okay, so we're just going to use the 10 and plug it here. So that Q2 should be 25 less half, open brackets. Where there is Q1 there, we're going to put 10. Okay, so our Q2 will be 25 less, now half of 10 is 5. Okay, so half of 10 is 5. You can still go on the calculator and punch. It's okay, it's fine, right? Yeah, so our Q2 will be the difference between 25 and 5, which is 20 units. So therefore, this firm can produce 10 from plant number 1 and 20 units from plant number 2. Right, so this is how we handle such questions. Okay, this is how we handle such questions. So right now, the logic is understanding the concept. That is the logic. Right, so it's just the issue of understanding the logic behind the calculations and the like. Okay, so this firm can produce 10 from firm 1 and from the first plant and 20 from the second plant. Yeah. So this is how we go ahead with that particular question. Now, the third part there. Okay, determine the profit maximizing price. This question, when you look at it, one can be scared and the like, but it's not that difficult even. Okay, why? Because in the statement we've been told that a monopolist inverse demand function is, so there's a function for price, and the question is asking us to get the profit maximizing price. Okay, so how do we do this? Well, so to find price, Okay, so to find price, step number one, okay, step number one, find total Q. So find the total Q, total output, total quantity. How? Remember that hint. I remember there was a hint that we talked about last time. There was a hint there where we're saying that the total quantity Q comes from the first and the second plant. So the total output that this firm can produce comes from plant number 1 and also plant number 2. Okay, so the first step is to find the total Q. Okay, so we know that Q is equal to Q1 plus Q2, and we know that Q1 is 10, Q2 is 20, so therefore this is just giving us 30. So meaning that the capital Q, the bigger Q, is just 30 units. What does this mean? Well, it means that this firm is able to produce a total of 30. But the next question will be, why are we finding this 30? What's the use of the 30? Well, we know that the question is asking us to get the price, the profit maximizing price. And in the statement there, we have been told that the price is 100 minus Q. So you see, if you don't get this Q, the 30, you'll be stranded, because you'll be asking yourself to say, which Q will I use? Is it quantity from the first firm or quantity from the second firm? You see that you end up getting two functions, so you end up getting two prices, which is not the right approach. The question is asking us to get the profit maximizing price and not the profit maximizing prices. Okay, remember, this firm is just one firm. Okay, this firm is just one firm, and this one firm is operating in two plants. So since it's just one firm, it is expected that it's going to be charging one single price. All right, assuming that there's no price discrimination, right? Yeah. Okay, so therefore our P will be 100 minus Q, and remember, we're just from calculating there that our Q is 30, therefore the price is 70. So therefore this firm will be charging 70 kwacha in both plants, plant 1 and plant 2. Okay, so this is how we handle such a question. Okay, am I alone or people have left for strategic? Okay, how is it so far? Is this okay? Is the pace okay? Or maybe I should slow down? Uh-oh. Madam Monde, can you hear me now? And are you able to see the screen?
Yes, I'm able to see the screen, and I can get you. Maybe slow down.
Okay, that's good. I'll slow down. Okay. Let's try to handle the next question and see how far we can go. Right, so what I'll do is I'll erase this side. Okay, let's look at the second part 2. Well, so now remember when we started, I was explaining about Conot. I thought we were looking at the second part. Yeah, so part 2 is now for Conot, oligopoly. So practically, part 1 and part 2 are somewhat related. Okay, you find that the steps are the same. Maybe it's just some terms that are a bit different here and there. Here we'll be talking about reaction functions and the like. Otherwise, the logic is the same. So part 2 is saying the inverse market demand in a homogeneous product Conot duopoly is, so we have just a second. Hello. Yo. Muliko. Mene mumfika kuchongwe. Okay, let's continue. I'm sorry about that. I'm really sorry. Okay, yeah. So you have the inverse market demand in a homogeneous product Conot duopoly is. So it's the same logic as you can see. We're still dealing with an inverse demand, but please, word of caution. There are times when they will just, let's say, they'll just give us a normal demand function, right? The one that starts with Q. And then they'll ask us to do this same thing here, right? To get the reaction function and the like. So when you find yourself in such a case, you have to get the inverse demand function. Why? Because for getting to get the reaction function, so I'm trying to respond to the first part. To get the reaction function, right? To get the reaction function, step number 1, get the total revenue function. Okay, so can you get the total revenue function? Okay, get the total revenue function for each firm. Okay, so should get the total revenue function for each firm. So that's the first step. But remember that, okay, for us to get the total revenue, right? For us to get the total revenue, so total revenue is equal to price times quantity. You see that? So in an event that, let's say, we've been given just a normal demand function, let's say, instead of having the inverse demand function, let us assume, right, that we were given the normal demand function. So I'm trying to come up with one. Okay, so since our P is 100 minus 2 capital Q, we know that we can make Q the subject. There's something that I want to show you. This is not part of the solution, but there's just something that I want to share. So, let me actually say, if we've been given an inverse demand function, like this one, now let's say we want to take it back to the original demand function. Okay, we have to make Q the subject of the formula. How can we do that? Well, we can get the 100 the other side, right? Then divide throughout by minus 2, right? So this can be P less 100 is equal to negative 2Q. Then we divide throughout by minus 2 like that. You see that? Okay, so that our Q, which is the normal demand function and not the inverse, will just be negative half P plus 50. You see that? So this is the original demand function where the inverse demand function came from. So now I was saying that there are times when they will just give you this function here and ask you to get total revenue. You see that? So in such a case, you have to go back to the inverse demand function and then use that inverse demand function to do the mathematics. Can you hear me? Okay, can you hear me?
Yes.
And I'm sure the screen has disappeared, right?
Yes.
Oh,
Yes, it does.
okay. I've gotten a notification even here, and I've asked that question. I'm just praying it's not things to do with bundle. Otherwise, that is a disaster now. Okay, yeah. Let me just reshare my screen so that I can share the whole thing. Okay, so kindly confirm if you're able to see the other, because I'm now using a different app. That one was misbehaving. So Mr. Senkara, if you're still there, just confirm so that we carry on.
Yes, but not yet able to see what is being displayed there, but we can see the screen which you are presenting there.
So it's just a white screen, right?
Yes, the screen is showing even the people that are joined this call, but there is no displayed presentation.
Oh.
Maybe try to put something on your screen, then maybe it will come.
Okay. Sometimes when these things try to, yeah. How about now? Still nothing.
We are able to see now.
Okay. So, this one I've not used it before, but we'll try to use it today. So, oh yeah, so I easily get disturbed. Okay, yeah, so we are trying to get the reaction function for FEM 1 and FEM 2. Given that here we have that the inverse demand function, which was 100 minus 2 Q1 plus Q2. Okay, yeah, so that's our inverse demand function. And then the data that we've been given is that the cost for the first plant is 12 Q1, and then the cost for the second plant is 20 Q2. Okay, so this data has been given from the statement. right? So what we want there is to get the reaction function. So I was saying that to get the reaction function, okay, yeah, so to get the reaction function, we've said that the first step is to, so step number 1, get the total revenue function. So let's get the total revenue function first. And I was explaining that total revenue is just equal to price times quantity, right? So in our case, the price that we've been given is this one here. Okay, that's the price that we've been given. So we'll have to work with this price, this function for price. So our total revenue, okay, our total revenue for firm 1 will be equal to the price multiplied by Q1. So I will say where Q1 is the quantity, okay, where Q1 is the quantity for plant number 1. So for plant number 1, remember we've got a monopolist. In this case of a Connaught oligopoly. So this should be for firm 1. So that is for firm number 1. So where Q1 is the quantity for firm 1. Okay, so our total revenue for firm 1 will be price, but the price that we've been given is 100 minus 2 open brackets Q1 plus Q2. This function here is just for P, price. Okay, so that function there is just for price. All right, so this function here is just for price. But are you trying to say something?
Yes, sir. Are you writing? Because it's like you're writing ended that total revenue equals the price times quantity. That's all. The other things which you have written, some more things, me I can't see on the screen.
Okay. Madam Mulenga, are you still here? Can you still hear me?
Yes.
Are you also experiencing the same problem?
Okay, now they've come.
Now you can see it.
Yes.
It has come now.
Okay. I think it's my internet. Okay, yeah. So total revenue is equal to price times quantity 1.
It's taking time to display as you are writing, maybe a minute or seconds. That's what's going to display the writings.
Okay. Okay. So the way we get total revenue, it's by multiplying price and quantity. So in the question, we've been told that price is 100 minus 2 Q1 plus Q2. You see that? So now, this thing that we've written here, okay, this is just the price, which must be multiplied by quantity, because total revenue is price times quantity. Okay, so this will be total revenue is equal to, now it will be a bit difficult for us to multiply it the way this thing is here. We have to simplify it. Okay, how can we do the simplification? First thing first, can we open those brackets there? Okay, so that's the first thing. Can we open those brackets there, so that we have 100 minus, now we can distribute these two throughout. Okay, so this will be minus 2 Q1 then minus 2 Q2. We are saying that this should be multiplied by quantity. You see that? But remember that we want to get total revenue for firm number 1, which means that total revenue for firm number 1, remember here we said that total revenue is equal to price times Q1. So this Q here should be Q1 instead. Okay, so I just forgot to put a 1 there. So we are multiplying price multiplied by quantity 1. But the function for price has got components of Q1 and Q2. So we're supposed to open the brackets and distribute the negative 2. In short, what we have now here is just the total revenue function for firm 1, which is not complete. Okay, so the next step is to simplify what we have. So how can we simplify? So total revenue 1 will be, we are going to multiply throughout by this Q1 here. In short, this Q1 should multiply by the 100, it should also multiply by this term here, and it should also multiply by that term there. Okay, so we can start. 100 multiplied by Q1, this will be 100 Q1 minus, we put a negative sign, Q1 multiplied by negative 2 Q1. Okay, so this will give us minus 2 Q1 squared. Okay, then we put the minus sign, then Q1 multiplied by 2Q2. So it's more like we are saying 2Q2 multiplied by Q1, which will just give us minus 2Q1 Q2. Okay. Yeah, so this will give us minus 2 Q1 Q2, like that. So now this is the correct total revenue function. So remember, what we want is to get the reaction function, but before we get the reaction function, the first step is to get the total revenue function. So let me just get feedback to ensure that we are okay. Are we okay with how we get the total revenue function?
For me, I'm clear. I don't know about others.
Okay. And is this thing still lagging?
No, there is an improvement.
Okay, that's good. I guess I just have to get used to using Airtel. Okay, so now the second step is, after getting the total revenue function, okay, the next step is to, so I'll try to erase this side so that we can use it to progress. The reason why I don't like this thing is that it doesn't give that privilege of, you know, moving from side to side and the like. It's just one page. Yeah, so after getting the total revenue function, step number 2, okay, step number 2 is to get the marginal revenue function. So step number 2 is to get the marginal revenue function. So step number 2 is get the marginal revenue function. So can we get the marginal revenue function? And I'm sure by now we know that we get the marginal revenue function after differentiating the total revenue function. Okay, so now the funny thing, or the funny part with our function, is that for us to get the marginal revenue function, we have to use partial derivatives. You see that, right? So we know that marginal revenue is equal to the derivative of the total revenue function with respect to Q. But in this case, remember, we are trying to get the marginal revenue function for firm number 1. So therefore, this will be marginal revenue 1. Then we are differentiating with respect to Q1. So as you can see, in the function for total revenue, there is Q1. Even there is Q1. But here we have got Q1 and Q2. Now understand that we are going to use partial derivatives. Okay, so we're going to use partial derivatives. Why partial derivatives? Well, it's because the function we are dealing with has got two components. There's the component of Q1, and then there's the component of Q2. So we'll have to partially differentiate the total revenue function with respect to Q1 in this case. Okay, so to get the marginal revenue function for firm number 1, we are going to differentiate the first part here, the 100 Q1 with respect to Q1. Okay, so we know by now that differentiating that term, okay, so the first term is 100 Q1. We know that if we want to differentiate this with respect to Q1, we know that this Q1 is raised to the power 1. Please don't forget these simple steps. Don't. Okay, they're very important. So we know that this will be the one on top will drop. We're going to multiply by 100. We're going to multiply this by Q1, and then from the power of Q1 we're going to remove a 1. So this will be 1 minus 1. Okay, so this will be 1 times 100 multiplied by Q1, and this Q1 is now raised to the power 0. Why? Because 1 minus 1 is 0. Anything raised to the power 0 is a 1. So therefore this will just be 100. What does this mean? Well, it means that differentiating the first part there, the 100 Q1 with respect to Q1, is going to, or the answer will be 100. Okay, so the answer there will be 100, meaning that meaning that there we are going to have our 100. Okay, the second term is negative 2Q1 squared. Now, can we deal with the 2Q1 squared? Can we differentiate this with respect to Q1? Alright, we know that this time around our Q1 is raised to a power 2. So this will be the 2 on top, we have to drop. We multiply it by 2 down there. Then we multiply this by Q1. Then from the power of Q1, we are going to remove a 1. So that 2 times 2 gives us a 4. We are multiplying this by Q1. And now Q1 is raised to the power 1. So this one, we don't need to show it. So therefore, differentiating the second term there, 2Q1 squared with respect to Q1 gives us a 4Q1. So we put our 4Q1 there. Okay. Next is to deal with the minus 2Q1 Q2. Remember, we are differentiating with respect to Q1. So now, so we can put a negative there. So we are dealing with 2Q1 Q2. We want to differentiate this with respect to Q1. Now, look at this. Here, Q1 and Q2 are more like linked, because this whole expression is multiplicative. Okay, and the way we handle such is, yes, we are going to differentiate this term with respect to Q1, but since Q1 and Q2 are connected, they are linked, because this is multiplicative in nature, we'll have to put back Q2. In short, we are not going to completely get rid of Q2. We'll have to put it back to our final answer. How? We are differentiating with respect to Q1, yes. And we know that this Q1 is raised to the power 1. First step. Okay? The next step will be doing just the normal way of differentiating, where that 1 for Q1 will drop. We multiply it by 2. We also multiply this with Q1. Then from the power of Q1, we know that we are going to remove a 1. But we should multiply this by Q2. We should put back Q2. Why? Because these are multiplicative. They are multiplying. Right. So 1 times 2 is just a 2. We are multiplying this by Q1. But now our Q1 is raised to the power 0. Why? Because 1 minus 1, the answer is 0. Then we're putting back our Q2 like that. And we know that anything raised to the power 0 is a 1. So this is more like saying 2 multiplied by 1 multiplied by Q2. Like that. Alright? And 2 times 1 is just a 2, which we're multiplying by Q2. What does it mean? Well, it means that differentiating that last term with respect to Q1 gives us 2Q2. So what we have now is a complete derivative. Okay, so that is our marginal revenue there. Okay, so I know that there are still some issues here and there when it comes to differentiation. No wonder I find that every time we're doing something with differentiation, I go back to the basics. Okay. How is that part for getting the marginal revenue? Madam Ruth Piri, can you hear me? I know, Mr. Sankara, you can go ahead.
Yes, for me, it is very clear, actually. Very, very clear. I don't know about others like James, Ruthie, Monde, Cynthia. I don't know about the rest.
Okay. Madam Monde.
Mr. Nugumi, I suggest you just come again on the marginal revenue.
Okay.
If-
Okay.
Yes.
Okay. Okay.
Yes.
Okay. Not a problem. Okay. All right. Cool. So what it is this, right? When we are differentiating a function, okay? When we are differentiating a function, let's say a function is, y is equal to a x to the power n. All right. How do we differentiate such a function? Well, this is what is called the dy dx. Okay, and the way we get the dy dx is, first thing first, we know that this a here is the coefficient, right? So that's our coefficient. This x is the actual variable itself, and then that n there is the power. So to get the dy dx, the power there will drop. Okay, the n will drop. Then we're going to multiply that by our a, and then we're also going to multiply it with the x. And since we're differentiating this with respect to x, remember that initially our x was raised to power n, right? So now what we're going to do is, from the power there of x, which is the n, we're going to remove a 1. So that is going to become our derivative. But practically, let us say that our function was actually 4x to the power 2. the way we're going to differentiate is to get, of course, the dy dx by, we know that in this case our a is the 4, that x is this x, that n, the power there, is that 2 there. All right, so we know that the power should drop, so the 2 there will drop first thing. Then we're going to multiply it by our 4. We're also going to multiply it by the x, and then from the power of x we're going to remove a 1, so that we have 2 times 4, 8. We put our x, and then 2 minus 1, the power will just be 1. So when it's 1, it's just as good as not showing it there. So that is it, the differentiation there. Now we want to apply this same concept here to differentiate this big function that we've been given in this case. So the logic is just the same. Okay, the logic is just the same, there's no difference. Okay, so let me erase the first part so that we can have, I know we're concluding. I know this has taken us more than the usual time. I'm sorry. Is it? No. We still have some 6 minutes, right? Okay, it's okay. I don't know how my mind was lying to me that it's beyond 9:30. Those hiccups we had. Okay, wow. Okay, yeah, let's try to work with this big guy here. So our function, the one we're trying to differentiate, is this one. So right, the left corner there, top left corner. So I've got 100 q1 minus 2 q1 squared, and then minus 2 q1 q2. Right, so this is our total revenue actually. So we get marginal revenue after differentiating the total revenue function. So our marginal revenue will be the derivative, so d so since in this case we've got 2 terms, q1 and q2, this is where we're going to put that inverted 6, that, okay, with respect to q1. So this here is telling us that we are going to partially differentiate the total revenue function with respect to q1. So that is what we are seeing right there. Okay, so now can we do this? Yes, we can. The first part, 100 q1. Remember, we are differentiating with respect to q1, right? So our marginal revenue will be, now look at this, the first part is 100 q1. It's 100 q1. We know that the q1 is raised to a power there 1, and since we're differentiating with respect to q1, that 1 there will drop. We're going to multiply by the 100, which we should also multiply by q1. Then remember, the logic is to remove a 1 from the power. So here in the example we're using x, but in the actual question we're using q1. Okay, so this will be 100 multiplied by q1 to the power 0, because 1 minus 1 is 0. And mathematically, or in mathematics, in this case, let's say in economics, okay, anyway, yeah, mathematically anything raised to power 0 is 1. So therefore, since q1 is raised to the power 0 there, this is the same thing as saying 100 by 1, which is just 100. Meaning that the first term there after differentiating that first term with respect to q1, we're just going to have 100. Okay, hoping that that has helped. Going to the second term, which is minus 2 q1 squared okay, so the second term there is minus 2q squared. So I've got minus 2q squared. So what we can do is we can get this guy, we put it here, so that we can just deal with a positive function. I'm doing this so that we can reduce the ambiguity. Okay, so we're dealing with this guy here, 2q2 squared. So q1, sorry. So we want to differentiate this with respect to q1, right? So that power there, the 2, will have to drop, then we multiply with everything. So this will be 2 on top multiplied by the 2 down. We're going to multiply this by q1, and then from the power of q1 we're going to remove a 1. You see, so the steps are just the same. So this will be 2 by 2, 4, multiplied by q1. Why? Because 2 minus 1, the power there, 2 minus 1, the answer is 1, right? So at the end of it all, okay, at the end of it all, we know that after differentiating the second term with respect to q1, this is just giving us negative 4q1. And then now the last part there, these two terms q1 and q2 are multiplying. So this is where we say that we are going to differentiate with respect to q1, but then we are going to put back q2. You see that, okay? So this will be 2 q1 q2, right? We know that since we're differentiating with respect to q1, we have to pay attention to the power of q1. Okay, and in this case the power is just the 1. So this will be, that 1 will drop, we're going to multiply with a 2. We're going to multiply q1, yes, but remember we're differentiating with respect to q1. So therefore, from the power of q1, we're going to remove a 1, and then put back our q2 like that. You see that? So this will be 1 times 2, 2. We are multiplying this by q1, but now this q1 is going to be raised to power 0, because 1 minus 1 is 0. Then we multiply back the q2. You see that, right? And we've said that anything raised to power 0 is a 1. So this is more like you're saying 2 by 1 by q2, like that. Okay, which will just be 2q2. Therefore, the answer for the last part there is just here you're going to put 2q2 like that. Okay, Madam Monday, hoping that has helped, right?
So much. But why didn't you not start like that in the beginning?
Well, Camille, the thing is, well, we did differentiation some time back, so my assumption was that, yeah, I'll share the recording. No. Actually, the recording was shared the other day, yesterday. I don't know, yesterday or the other day. Remember those 2 links I sent? There was one for differentiation, and then there was one for the class. I did that deliberately because I knew that people have got issues with differentiation. So please take your time. You listen to that video. It's very informative. Listen to it. Yeah. Because Monday differentiation is a tool that we'll have to use until we write the exam. It's a very